Hey guys, this is Lucas Wilkerson, the math coach. I'm going to be working through some problems. So this one says find the slope of the line that goes through the given points, and we're given 2 points. So we'll just want to label these as like x1, y1, because this is an x and y point, and this is x2, y2. Then we find the slope, which is often called m. So m equals the slope, that's how you'll see it. We need to remember our formula, which is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. We just need to plot these in for what we said it was up here. So -5 minus -7, 6 minus 9. Simplify to 2 over -3. And yeah, that's going to be our answer. That's how you find the slope. Number 2, use the given conditions to write an equation for the line in slope-intercept form. So when it says slope-intercept form, it's thinking like this: y minus y sub 1 equals m times x minus x sub 1. So you'll see we have the m in there, so we're going to want to find the slope for our 2 points again. We'll start by labeling things: x1, y1, x2, y2. The slope is m, and plugging in the new x1, y1, x2, y2, we get 7 minus 2, 7 minus 3 equals 5/4, 5 over 4. Then we'll take it in, we'll plug it in to this equation to put it in slope-intercept form. So this is like part 1, now we're going to do part 2. So we're going to get y minus 2 equals 5/4, that's what we just found, times x minus 3. We'll distribute the 5/4 into each of these. Then we'll add 2 to both sides. That would be our final answer. Now for number 3, graph the line whose equation is given. Since the equation is given, we just need to solve for m and b, m being the slope, and b just being our starting position. So m in this case, we can just look at it. See, it's -3 over 1, found right here. And then b is just what it's added to, which is +2. So that means we can plot 0, +2. We can plug in some more points, but what's going to be even easier is just using the slope, since we know it's going to go over to like this. So for every 1 point in the x direction, we're moving -3. So there. Trying to look real precise, my eyes aren't the best. So this is sort of where our points would line up. And then this blue line will just be the graph, and that's like a rough estimate, but you get the idea. Use the slope. For number 4, graph the equation in the rectangular coordinate system. Here we don't have an x and y, so we're just going to solve it in terms of x. So we'll get x by itself. We'll add 2 to both sides, leaving us with 8x equals 40. We'll divide both sides by -8, and we're left with x equals -5. So we're going to look where x is -5. Here's one instance where it is. And what we're going to want to do is have every instance that it's -5, because that's our graph. So it's just going to be this straight vertical line. Now looking at section 2.4, Start with number 2. Passing through point 2 comma 4 and perpendicular to the line, whose equation is 8x plus y minus 6 equals 0. Get the slope-intercept form. So, just like previous problems, first we need to get the slope, and then 2, plug into y minus y sub 1 equals m x minus x sub 1. So getting the slope, we're going to use the equation they gave us, and we're going to put it in the form where we can evaluate it. So adding, oh wait, I wrote this wrong, that's why I'm confused. Add 6 to both sides and add 8x to both sides, and we'll get this. And then we can observe that this is going to be m, the 8. That's our slope, but since this question said it's perpendicular, when you take the perpendicular slope, you need the negative reciprocal. So it becomes negative 1/8. Now we just plug into the formula that we're given. I'm just using the point that they gave us in the problem and the slope that we found down there. We distribute the negative 1/8. Add 4 to both sides. And this would be our final answer. Next problem number 4, find the average rate of change of the function from x sub 1 to x sub 2. So when it talks about average rate of change, they're talking about this formula, ROC, average rate of change, which is f of x sub 2 minus f of x sub 1 over x2 minus x1. And that f of x sub 1, f of x sub 2 is just going to be the different equations in this case. So for example, we can call this f of x sub 1. No. Not that's f of x sub 1. We're given the points x sub 1, x sub 2, so we're going to plug those in f of x. F of x sub 1 is f of 5, which is negative 3, 5 squared minus 5. So that's just plugging into the equation we're given. If you punch that in your calculator, you'll get negative 80. F of x sub 2 is equal to plugging 6 in. Plug into your calculator, you get negative 144. Now, to use the equation we're given, f of x sub 2 is our negative 144 minus f of x sub 1 is negative 80. Then x2 is the 6 that we're given minus x1, which is our 5. Simplify this, it's all going to be over 1. This becomes a plus. And our answer is negative 34.